Hello fellow mathletes, today I will explain you the formula of integration by parts because I've been using this formula in my other videos and I haven't explained it till now. So let's discuss it how it works. In integration we often experience we often face functions that are multiples, that have two functions in an integral. So to solve such integrals we use a formula. It's called integration by parts. So let's assume that there's a situation which there's an integral which has two functions, f of x and g of x. Now the integration by parts formula, to implement the integration of by parts formula, we will call this function the first function and this function the second function. That's just an arbitrary notation. Now what we do is that to solve this integral, we will write the first function as it is and multiply it with the integral of the second function only. Now the integral of g of x is here, minus the whole integral of the integral. Again, in the integral there is another integral of the second function and the derivative of the first function. So that's basically how we perform integration by parts. So if I write it down descriptively, first function as it is, multiply by the integral of second function, whole integral of second function, multiply by the derivative of the first function. So integral of g of x here and derivative of f of x here. So this will give us the by solving this we can get the solution of the integral. For a very simple example, I have used here x sine of x dx. In this equation, in this integral, you see there are two functions, x and sine of x. So to solve it, we will use the integration by parts formula. I've made x the first function and sine of x as the second function. Now the selection of first and second function is sometimes very tricky. If I use the sine, first let me solve, then you will then I'll explain. So I've used x as the first function and sine of x as the second function. So first function as it is, I've just implemented the integration by parts formula, and the integral of the second function. The integral of sine of x is minus cos of x, minus again the integral of sine of x is minus cos of x, and the derivative of x. The derivative of x is 1. So the expression becomes minus x cos of x plus cos of x times 1 dx. Now again x cos of x plus sine of x, that's the solution. Now as you can see, if I had used sine of x as the first function and x as the second function, this integral would have expanded instead of converging. It would have diverged in a sequentially longer integral. If I used x as a second function, here I would have had to use the integral to integrate x. The integral of x is x squared by 2, and again in the subsequent integral I would have to again integrate x, and it would again become x 3 by x cubed by 3. So to get a solution of using the integration by parts method, we have to be very smart about choosing which function to be the first and which function to be the second. As a rule of thumb, if there are no inverse trigonometric functions or logarithmic functions or algebraic functions involved, then always use if there are no inverse trigonometric function or logarithmic functions involved, then always use the algebraic functions as the first function and any other function as a second function. But if the inverse trigonometric or logarithmic functions are involved, then we will always use the inverse trigonometric functions and logarithmic functions in that order as the first function, because the derivatives of inverse trigonometric functions exist, the derivatives of logarithmic functions exist, but the integrals of these functions do not exist. We have to evaluate the integrals by using tricky integration by parts techniques. So that's how we use the integration by parts method to solve integrals which involve multiple functions as products.